However, sometimes you don't want to analyze a batch of file. You actually want to analyze a simple file, a single file, no? A single CDF file. In this case, we have another function. Like actually, you have three functions that do exactly the same processes that we described for matreport base peak, matreport area, and matreport. So we have the same functions, however, in a version for single files. So the matreport version for single file is called matreport file. In this case, what we need to point, instead of the main folder, we point to the CDF file. So here, the arguments that it requires, instead of data, in the case of data, here is not anymore the main folder that we pointed before, but now we point to the CDF file itself. The second argument is the EMS library, is the EMS report, sorry. The third argument is the EMS library. Then save, time window, and the output that you want. And if you want to remove any compound, it's the same idea. You add the name of the compound that you want to remove. Okay, so in this case here I don't want to remove. Let's just see how it works. What's the difference between matreport file and matreport? So I have already set here the folder. The CDF file that I chose here is this one. As you can see, 50_1. You have here the EMS reports, the same one that you have been using, and here the same library that we used before. Same idea. However, here the name of the output file will be testing Metab file. Okay. So there is already one test Metab file here, so I will remove this one just so I don't get confused. Actually, I will remove all of the files we generated in this last running all these functions. So clean all this rubbish, then we don't get confused. So if you run this function here now for a single file, it runs exactly the same process that it ran before. So here it shows that you have, when it converts the library from the EMS format to the format we need, you have here again the warning saying that those compounds, they have similar retention times and similar ion mass fragments, the same information. So this file here was analyzed, and if I see the results, now I have the name of the metabolites and their abundance in this single sample. So the difference now is that I have a single sample, and now because we don't have a folder like those subfolders to define the experimental condition related to each sample, the replicates here, we give them a letter. In this case, the name of the replicate is A. Okay. So that's the main difference. And the same idea works for area and base peak. So if I want to analyze the same sample, but now using area and the base peak, so here the only difference that you're going to have in relation to the matreport file is that in this case of the area matreport file area, we return the area calculated by Amadeus. So in this case we don't need to recalculate the abundance, so we don't need the EMS library anymore. So this MSL file here we don't need to add, so we just need to the CDF file and then the EMS report, and probably it's going to ask where I'm going to save the file as well. So let's try to run the way it is. So instead of testing Metab file here, I put test Metab area. However, save is false, so it's not going to save anything, so I'm going to change it to true. Because here it was false, that's why it didn't save any file here. So, but here we put to true. And actually in this case, we need to say where it's going to save the file. That's another difference between these three files to the other files we showed before. You actually have to say where is the folder where the files will be saved. So I'm going to save the files in this folder here, example Metab. So for this I can use the option here, folder equal this folder where we are working for now. So if I execute this function now, it's pretty quick, you can see, because it doesn't recalculate the abundance. Then you have here the files that were saved. So testing Metab file area, this one here. So we have the file, we now calculated the area. You can see the difference between these values here and the values that we had before, because this is the area and that's the abundance of the most abundant ion mass fragment, which will be pretty close to the base peak calculated by MDIS. So if you calculate perform exactly the same analysis that you perform now, but now using the base peak instead of the area. So let's change here, testing file base peak. You must have a pretty similar result as the one we had for this function here, which is these results here, those abundance. So the base peak calculated by M is pretty similar to the abundance that Metab recalculates. So let's see if I execute that. Now I have here base peak, and these values here, as you can see, are very similar to the one we calculated. So the only difference between this value calculated by MDIS and the one that we calculated, again, is that we guarantee that we are comparing exactly the same reference ion mass fragment across conditions, while MDIS may use different ion mass fragments according to the sample. So that's the main difference. In this case, for instance, it's clear that it's using exactly the same ion mass fragment because the values are pretty similar.